Hi, this is AS Computing. So in this video we will be looking at hierarchy charts and stepwise refinement. Firstly, hierarchy charts. Top-down design is an approach to problem solving that takes a goal and breaks it down into a series of sub-goals that leads to the solution. Now, this acts as a planning tool for breaking down the problem. A hierarchy chart can be used to describe how this is done in a visual form. So each smaller problem or sub-problem becomes a separate module which is solved on its own. The solution from the combined sub-problems would most likely lead to a unified overall solution and allow the owner of the problem to reach a goal. So a great advantage of having these smaller sub-problems is of course that it breaks down the problem into smaller, more easily computable chunks of data sets. I mean, you will very often have a lot of data to digest, so breaking them down into smaller pieces will make it easier to compute, and therefore it'll make it easier for you to reach a goal. So is an example of a hierarchy chart, and let's just take a laser pointer here and let's see. So the blue part right here would signify the problem. So there may be an overall problem right here, and this is the visual format of how it would be done. So it would be broken down into these three sub-problems. It doesn't have to be three, it can be more than three or less than three. What matters is that it is broken down into sub-problems, and then of course it is solved as a separate module. Okay, so the next part is stepwise refinement. So another approach to breaking down a large problem into smaller parts is stepwise refinement. So it involves identifying the major steps involved in solving the problem. Each of these steps is then divided into sub-steps. If necessary, each sub-step is divided into another sub-step, and so on. Now, the major difference with stepwise refinement and hierarchy charts is that stepwise refinement has these levels, or as it says in the writing, major steps that are involved. And these are the key points that differentiate it from the top-down design. These steps and sub-steps can be very easily illustrated in a structured table. The indents and numbering systems of such a table allow for a very easy ability to break down and compute the problem. So, example of a structured table. So we would have our main problem right there would be to do the weekly shopping, and then we'd have the major step or a level. So it would be to prepare a list, and these would be the sub-steps we're taking for that major step. And then we have another major step, do the shopping, so we do those. And then we have another major step, and then we do the sub-steps for that as well. Now, a good key to remember is that the indentation and numbering help us to interpret the table. So these we can obviously see that this is an indent of that. So this helps us to see how it's stepped down. So this is the problem, this is a major step, this is a sub-step. So the indentation is vital for us to interpret the table. Furthermore, the greater the indentation, obviously the more detailed the steps would be. So perhaps the check cupboards might have, if the problem was more complex, might have other sub-steps which would be further indented. and of hierarchy, charts, and stepwise refinement. Thank you for watching.